Hello everybody, today we're going to be learning about Pythagorean triples, which come from the Pythagorean theorem a squared plus b squared, which are a and b is the small legs of a 90-degree triangle, and c is the big leg of a 90-degree triangle known as the hypotenuse. Now, how do we find them? How do we find Pythagorean triples? Now, these are things you must know, and you should take down. Now, we need to know the equations for a, b, and c, which are a, n squared minus m squared, b, 2n times m, and c, n squared plus m squared, which a is the difference of squares, b, twice the product, and c, the sum of squares. And then, knowing this, you must definitely remember the fact that n is always greater than m, and n and m are both integers. Now, what do we need to know in order to make sure that we have the right Pythagorean triples? What we need is proof. Now, what is proof? Proof we will get by using the equation a squared plus b squared equals c squared, which then we need to remember the equations for a, b, and c. Now, once we know these, we need to plug them in for a, b, and c, and square all of them, which would be a squared, which would be n4 minus 2n squared, m squared plus 4, and then b, once we squared the equation of b, it would be 4n squared times m squared equals c squared, which would be n squared plus 2n squared, m squared plus m4. Now that we've distributed and we look to our left side, what we need to do is combine like terms. To do so, it would give us n to the power of 4 plus 2n squared m squared plus, sorry about that 4, it's supposed to say m to the power of 4, there you go. Now we equal it to the right side, which would be n to the power of 4 plus 2n squared m squared plus 4, showing us that both of them are equals to each other. This proving that they are indeed Pythagorean triples. Now, let's try something else by ourselves, remembering that n is greater than m and both are whole positive numbers. Example number 1, where n equals 6 and m equals 3. We plug them each into the equation for a, b, and c, where it's n squared minus m squared, 2n minus m, and n squared plus m squared, which would then leave us to the result of having 6 squared minus 3 squared, and then 2 times 6 times 3, and then c, 6 squared plus 3 squared, which would then give us for a, 36 minus 9, giving us the answer of 27, then leading to 12 times 3, giving us 36 for b, and then c, 36 plus 9, giving us 45. Now, how do we know if these are Pythagorean triples? We need proof by, of course, using the equation a squared plus b squared equals c squared. Now, let's go ahead and lay them out for the equation a, b, and c using a squared b squared equals c squared, where we plug them in, and then it would be 27 plus 36, 45. Let's give them all a square, giving us 229 plus 1,296 equals 45 square. Now we add a and b, and then equals them to c, which give us 2,025, proving that both of them are equal, which shows that a, b, and c, being 27, 36, and 45, are indeed Pythagorean triples. Now let's move on to example 2. Using n equals to 8, and then m equals to 4. Now we laid them out for both the equations for a, b, and c. Now given us a equals 48, b 64, and c 80, leaving them to the proof by using the equation of the Pythagorean theorem, which now we have a square, b square, and c square, giving us a total of 2,304 plus 4,096 equals 80 square, which would be 6,400 equals to 6,400, showing us that a, b, and c being 48, 64, and 80 are indeed Pythagorean triples as well. Now try yourself using n equals 9 and m equals 6. Pause this video for the answers later on. Now that you've continued, these are the answers. A, B, and C, having A being 45, B being 108, and C 117, which then, as we plug them into the equation, it gives us 45 squared plus 108 squared equals 117 squared. Solve for that, giving us the total of 13,689 equals to 13,689, which then proves to us that A, B, and C being 45, 108, and 117 are indeed Pythagorean triples.